Hello students. So today in our class we are going to discuss about refraction by the spherical lenses. In the previous class we have discussed about refraction and as well as refractive index. Based on that concept we are going to start new concept, that is refraction by the spherical lens. So now what is this lens means? A transparent material which is bounded by two surfaces. That means lens will be having two surfaces will be there, in which one of the surface may be spherical and another one's surface may be plane here. So in this case there are two types which we are going to study in our 10th standard. One is convex lens and another one is concave lens. Okay, so one is convex lens, another one is concave lens here. In this case, first if it is, we are going to discuss about the convex lens. Means in the case of convex lens, two surfaces are spherical itself. Okay, two surfaces are spherical surfaces, and also this convex lens, how the convex lens will be, the convex lens will be like this. It will be bulging outwards. Okay, the lens, spherical lenses will be bulging outwards, in which middle will be thicker one compared to that of the edges. This is about the convex lens, and also this convex lens is also called as converging lens. Convex lens is also called it as the converging lens. Similarly, what is this concave lens mean? Concave lens also, the two surfaces will also be a spherical surfaces, and also how the concave lens will be there means the concave lens will be bulging inwards. These are bulging inwards, this is the formation of the concave lens. This concave lens will be thinner at the middle and thicker at the edges, and this is also called it as the diverging lens. So converging means they will converge to a point, diverging means diverges away from the point. Okay, that is the main you have to understand about convex and as well as the concave lens. Now we have to know what are the parameters will be there. In the case of the mirrors, you will be having center, you will be having focus. Same thing will be there, but certain difference is there. If you have considered this is a lens, convex lens I have considered, you can able to see there are two surfaces, two spherical surfaces are there. So two spherical surfaces means they will be forming a sphere. This is one sphere. So another one will be forming, this is another one sphere. Okay, so this point, this middle point of the lens is called it as optical center. This point is called optical center, that is represented by O. Okay, and this is the sphere. The center of that sphere, here you are having the two spheres will be having. This center is called as C1, and the center of this sphere we are going to call it as C2. Okay, and the line passing through the center of the spheres is called the principal axis. Okay, so principal axis here is nothing but a line which is passing through the to center of curvature, or line passing through the center of curvature, and the optical center is called the principal axis. Here C1 and C2 represents the principal center of curvature. So they are called as center of curvature. Okay, so this is how we are going to define the parameters in the case of the lenses. This is not only for the convex lens, it is also for the concave lens also. In the concave lens also, the same procedure we are going to follow it. So instead of, we can, this one C1 and C2, we are going to denote it as, so this is the lens. If I consider this is a lens, this is the optical center of the lens, and this is the principal axis for that. And here if you have considered, this is the C1 center of curvature and this is the C2 center of curvature. You know, in between the center and as well as center of curvature, there comes the focus, isn't it? That is the focus here, and that focus we are going to represent here, it is F2, and this focus we are going to represent as F1. So if we are representing this as F1 and F2, so instead of writing in the ray diagrams, instead of writing C1, we are going to represent as 2F1. You know, C1 is center of curvature is nothing but 2 times the focus, isn't it? So that means instead of C1 we are going to represent as 2F1, and instead of C2 we are going to represent as 2F2. So this is how the parameters which you are going to define for in the case of the lenses, not only for convex, it is also for the concave lens. Here we have to consider 2 things which is very important in the case of both convex lens as well as concave lens. Means whenever a ray of light has been passes through the center of curvature, that is this one, that is optical center, when a ray of light has been passed through the optical center, in that cases there is no bending of light, or I can say this is undeviated. It will, where it came in the same path, it will travel here. Similarly, if it is traveling in this position, when a ray of light is passing really against to that optical center, means in that case also there is no bending takes place. So this is the one thing we have to know about the lens here. So second thing, for instance, you can consider this is a lens here. In this case, this is the optical center O, and this is the F2, and this is the C2 I am considering. When a ray of light passes parallel to the principal axis, this is the ray of light which is passing parallel to principal axis, what happens? So you know, this is a air medium, this is a glass medium, isn't it? When light travel from one medium to another medium, that means from rarer medium to denser medium, the light will bend. Now the light bends and it will be forming like this. Similarly, when ray of light has been passing to this parallel to principal axis, in this case it will bend and they will converge to a point. That point it is called it as the, so this is F2 should be there. So that point which is converging to a point is called the principal focus, or it is called as the F1, isn't it? So this is the 2F1. So here I'll represent as 2F2 only. Okay. So this, whatever the ray of light, if you are consider after refraction, they will converge to a point. That point is called it as the principal focus. This is main thing. 2 things you have to understand. When a ray of light is passing through the optical center, means it will undeviated. That means no refraction takes place. In the case of when a ray of light is passing parallel to the principal axis, then that after refraction it will converge to a point, that is the principal focus. This is about the convex lens. Same thing we will discuss about the concave lens. In the case of concave lens also same thing, that is this is the optical center, this is the focus, second focus, and this is the center of curvature, this is the first focus, and this is the first center of curvature. Now in this case same thing, when a ray of light has been passing through the optical center, it is undeviated. That means no refraction has been taken place. Now similarly, when a ray of light is passing parallel to the principal axis, in that cases what happens? This is the F1 and this is the F2, F1 and as well as 2F1. So when it is passing parallel to principal axis, this is the ray of light which is passing parallel to principal axis. So this is how the refraction takes place. So similarly, when ray of light passing here, refraction takes place. So that means they will diverge from a point, isn't it? This is called the diverging lens because they were diverging. So this is the where it is going to diverge it. And also after diverging, if you have drawn an imaginary line, that backwards if you have drawn that line means you are able to see they will focus on certain point. That point is called the principal focus. So after drawing imaginary line, behind that you are getting the image is forming at the principal focus. Okay, so this is about how we are going to know about the lenses, that is image formation in case of the concave lens and as well as the convex lens. So if you have understand this, then only you can able to know about how the image will be formation, that is beyond C. Same thing, whatever we have discussed in the case of mirror, same thing you going to use in the case of the lenses. Okay, thank you.